Hi, in this video let me go briefly over the data analysis or the predictive analytics assignment. So those are kind of the list of the variables based on the variables that I provided you for the descriptive analytics. So those ones that are highlighted in yellow, they should not be included in the analysis because they are basically what we call them reference variable. So we should remove them from the analysis. If we didn't remove them, actually when you run regression, logistic regression, it will remove them, or the system XLMiner will remove them, remove one of those. For example, for race, we have here 4 options. At least for this example, for you it might be different, but at least here we have 4 options. So since we have 4 options, one of them should be a reference variable, meaning it should be dropped and not included in the analysis. If we have only 3, let's say those 3, then one of them should be dropped from the analysis, means not included in the analysis because it's going to be a reference variable. So now I highlighted for you those variables that are reference variables where they should not be included in the analysis. So now I'll show you an example. So this is a data set of one of the teams, and as you can see here, the readmit, this is our target variable here, readmitted. And remember, when this was created as less than 30 days, so any readmission that was in less than 30 days, it's going to be 1. If not, then it's going to be 0. So this is how this team created the readmission variable, which is the target variable. So now for us, the purpose of this prediction model or this analysis is to create a prediction model where we can predict those patients based on their characteristics here, whether they are going to be readmitted or not. And you have already cleaned the data based on what we have talked previously, and now you can just go ahead and run the analyses. So for me, it seems to be that XLMiner is not showing up, so I'm gonna add it as an add-in. And you might have noticed that XLMiner has some limitations in terms of how many records or how many lines records it can process. So some of you might have noticed that it says that it can, for the training portion, or partition, it can handle only up to 10,000. So now let's wait for it and see, add in. So I need to add this guy. Alright, so now I have it. It's a little bit slow because this is a large table and my computer memory is a little bit slow or very low. So the first step that we need to do is to partition the data set. And one thing that we need to consider is, if I created here a public table for the readmission, so I'll put readmission here and then count here, and as you can see here, the data set that we have for readmission, we have 11% that were readmitted versus 88 that were not readmitted. So the readmitted within the 30 days were 11% of our data set. So in this case, it is not proportionate. It's not 50-50%. So in this case, we will need to do a partition where we can over sample. So in this case, I will go to XLMiner and then partition. I'll go to partition over sampling, and here it's recognized all the columns, so I'll just select all of those variables and take them to variable in the partition data. Now I'm going to select my target, our output variable, and I will select the seeds and I'll put the output variable here. So as you can see here, 11% are the success or the readmitted, where the class is 1. So automatically it says specify percentage of success in training set, so I'll put 50%. Now it's asking me what percentage I need to put in the validation. Let's just put 85 as an example here and see what I will get. So it partitioned it for me. So it put for the training data, it put almost 5,600 records in the training partition, and it put 3,700 in the validation, and it put in the test partition 21,000. So that's fine. That's fine. It's not all the 50,000 that we have in hand, but this is fine. This is based on the limitations of XLMiner, since it doesn't allow us to because it's just only for education purposes, or this is the educational license. It has some limitations, so we are going to use this one. Now I have the data set ready for us. Now we can go ahead and do, because our target variable is categorical, so you should know by now, if we have a categorical variable, means like a binary variable, it's 0 or 1, then this is a categorical variable. If we have a categorical variable, that means we are classifying. If we have a continuous outcome variable or target variable, then that means we are predicting. We can run some of those, but now our output variable or target variable is readmission, readmitted or not readmitted. It is a categorical variable. So I will start with a logistic regression. So the first step, I will just select my output variable, it's readmitted, and then I will select all of them, and then I will remove those ones that we said they are going to be our reference variables. Okay, so let me get rid of this and put it this way, that way I can see them. So now, what did the bread? Where can I find that? Alright, so I'm looking for classify and logistic regression. That way I can see here. So I'll select all those variables. Oops. I don't need to select my outcome, so I'll select my outcome first, and then the rest of the predictors. Select them there. So specify the cutoff probability for success. It's always, as we mentioned, it is 0.5. So then we'll go next. So here we will set confidence level for odds 95%. Oops, I think we forgot to remove those. So again, here African American is a reference variable, so we'll remove it. And then between 30 and 60, so I'll remove that because it's a reference variable. And then let's see here, clinical or actually home discharge, because we have discharge home versus discharge other discharge, so it doesn't matter, we can just remove one. And then because and then we have clinical, remove that. And then cardiology specialty, let's see, remove that guy. And then missing unknown specialty, so either or, that's fine. So either this one or this one, but not both. And then diabetes, and last but not least is the now A1C result. So now we'll just continue, go next. And then the first time I will run it, I will not do the variable selection. We can do variable selection later, but first time I'll run it without variable selection. Those are not too many variables to reduce. So now let's look at the results. So we'll wait for it, it's processing. Alright, so now we get the results. Now the first thing is to compare or to look at the validation. So this is the percentage error in the training partition, and this is for the validation. It is 38, so it is less than the training error, which is great. And now let's look at the test. It is even less. So as you can see here, that this is what we have from the logistic regression. So 38. Now we can run some other tests using some other machine learning algorithms. So we used logistic regression. Now let's use neural network. So I'll go next. So that way we can compare those models and see which one will be best. So as we said, neural networks, we need to normalize input data. And then go next and finish. So we'll use the default. So far we had error rate, or the error percentage from the logistic regression was 38. So now let's see what neural network error rate, so the opposite of that 38 will be the accuracy rate. So the accuracy rate is approximately 62 for logistic regression. Now we will see what is the accuracy rate for the neural network model. So it's taking its time because it's a large data set. And the neural network, as you can see, when we talked about backpropagation, okay, let's see. The reiteration, there are tons of reiterations, so let's look at here. Validation score summary. So this is the training. So remember, the training error percentage error for the logistic regression was almost 40. So now the validation error is 48. It is much larger than the 38 for the logistic regression. So, but you get the idea here. So in comparison between those two, the logistic regression is performing much better. So logistic regression validation is 38 versus what we just saw here in the neural network, which is 48, almost 10% different. Now let's try our third one, our third test. You can use the classification tree. Okay, so this next. The node prone tree, I will just go next. And then the full tree. And see what it will tell us. I can pause to see. Alright, so now it gave us the results. So now let's see. So now we can see the full tree, the full grown tree. This is how it looks like. So feel free to show this in your presentation, and you can read at least one rule, one decision tree rule. So for example, here you can read this. So if the patient was not discharged home, and then the internal, what is internal med, and it was and he was or she was seen by internal medicine specialty, then they are going to be readmitted, more likely to be readmitted, right? So this is how we read it. You can at least read one in your presentation. But now let's get to the validation score. So this is the training. So what about the validation? It's not doing better than the logistic regression. Same thing here. Yeah. So you get the idea now. So you have now three models, three models from with three algorithms or machine learning algorithms, and then you compared them, and then you decided which one works best. And now we have seen which one and then you can decide which one is working best. So this is with this way, and we haven't partitioned yet. So going back to the logistic regression output and see here, or get rid of this one. So here you can see which variables had significant impact. So we can see this one, gender, and I believe this one was male. So if it is a male, the odds of being, so this is a very nice table that you can use to interpret. So this is, since it is significant and the odd ratio is higher, you can just say, and this is actually for male, male is 1, female is 0. So based on this result, it is significant and the odds ratio is 1.17. So that means males are more likely more likely than females to be readmitted within 30 days. So basically that's how we read that one. Let's look at this one also. Oops, let's see. So this one also, it is significant. So for those patients who are discharged home, they are less likely, because also here the negative sign, they are less likely to be discharged, they are less likely to be readmitted. So there is something, this data is telling us those who are discharged home in comparison to discharged to some other places are less likely to be returned to you know, to the hospital or to be readmitted. Very nice. And then what else? This guy also is significant. Basically length of stay. So for those, the more they stay, those who stay longer with at the hospital, they are more likely, because the ratio here, the odds ratio, if it is above 1, that means they are more likely to return. If it is less than 1, then they are less likely to return. So basically that's how, based on what we have discussed in this course. Or else, do we have something significant? We have those significant here. I don't remember what this one was, but you can see what this one other is, other specialty or other diagnosis, so you can see what this one here. Okay, high made change. Yes, this is what is really interesting. So when the A1C is high and the medication was changed, so then they are less likely to be returned. And when the A1C was high and no medication was changed, they are less likely to return. So basically there is something, there is a secret with when the A1C is measured, they are more likely to not to be readmitted. So this will be something interesting, kind of, you might have a discussion about it. See what more discussion do you have to talk about. So that's all that can help you with your project and writing the results. And then you can include, for example, the output, those variables, the coefficients and the odd, the p-value and the odd ratio in the results, kind of to show this one, at least since this is the model that you are going to use, and it's nice. So just do those and show those variables and so on. So that's all, and good luck to you.